Hello and welcome to today's class. For this class, we'll look at the study of strength of material as a course. We'll proceed to our next tutorial class now on strength of material. If you're interested in watching our full tutorial course on strength of material, simply check our playlist. You see the full tutorial course on strength of material. All right, let's look at the particular problems for the last 2 years, mechanical engineering. Let's solve this together and let's see how it works. One says a steel bar is 900 millimeter long. Its two ends are 40 millimeter and 30 millimeter in diameter. The length of each end is 200 millimeter long. The middle portion of the bar is 50 millimeter in diameter. If the bar is subjected to an axial tensile load stress of 50 kilonewton, find the total elongation. Take Young's modulus to be 200 giganewton per meter squared. All right, for that question there, this becomes your diagram for that question. By the way, you'll not be given this diagram in exam. You have to draw out this diagram yourself from this question here. So, by the way, let me say I have not done this. Let me do a rough sketch for you to see how I actually got this diagram. Right? So, here's the rough sketch. It says that a steel bar is 900 millimeter long. It means that the total length of the bar, total length of that bar is given as what? 900 millimeter long. So, from here to here is, of course, 900 millimeter. Mind you, the question says that its two ends are 40 millimeter and 30 millimeter in diameter. This end here is as the diameter of 30. This one is 40. So 40 and 30 respectively. So observe that if this one is 40 and here is 30, they can't be of the same height. So this is 40. It will be bigger than what? 30. So I have to reduce this one. Let me reduce this one in this case, in this sense, this way. So let's say this is what? Perhaps 30 in diameter. Observe, please. It has to be what? Smaller. This is 40, 30 diameter. And they said, and the question says that the length of each end is 200 millimeter long. So the length from here to the length for this one, this 40 millimeter is 200. This one too is what? 200. So what do they mean in that case? Observe that they said from here to here is 200 millimeter long. We said back here too, from here to here is what? Still 200 millimeter long, right? So I have this here. What next? Observe that I'm still left with something at the middle here, right? So let's see what the question says. The question says that the middle portion of the bar is 15 diameter. This is 40 diameter. This 30 smaller. 15 what? Smaller. Very smaller than 30. So I'll have 15 somewhere here. This becomes my 15 diameter. Observe. So something of this nature. So this is 40 in diameter, 30 in diameter, 15 in diameter, which makes sense. So that becomes, this is what I have at this point here, right? So this one here is 30 diameter, as I stated from the question. This one is for 15 diameter, while this one here is what? 40 diameter, right? So proceeding to from the question there. If the bar is subjected to an axial tensile load stress, last class we look at type of stress. We said we have tensile stress and compressive stress. For tensile stress, the arrow goes outward. For compressive, it goes inward. So I mean a tensile load stress, the arrow is going outward. What's the force of that stress? That's what the 15 kilonewton. So I have 50 kilonewton, 15 kilonewton there. That's my force there. So let's say find the total elongation. Take your modulus as this. So let's solve this one, please. How do we possibly solve this one? I'm looking for total elongation, right? So it means that for this bar now, I have three sections in this bar. Section 1, 2, and 3, if you can see very well. So I have section 1, section 2, and section 3. So it means that total elongation is that I'll look for total elongation as section 1 plus elongation as section 2 plus elongation as what? Section 3. I'll combine them together to form the total elongation. By the way, last class we look at the formula for elongation. We said E is equal to what? FL all over AE. We emphasized on this last class, right? So we look at this concept last class, that elongation is what? The product of force and length to its ratio of what? Area and near modulus. So last class we emphasized on this. So I think that I'll pick out this formula now. I'll solve for section 1 with this, 2 and section 3. Now, my first task now is that let's look at parameter, please. So the givens, perhaps given, what are we given there? This is, let's say this is section 1 here, section 2, section 3, right? So I have 3 sections there. So for section 1, that becomes my L1. What's the length of section 1? 200 millimeter. My L2 is what? 500 millimeter. My L3 is given as what? 200 millimeter. That's my length. Section 1 too has diameter. So diameter section 1, D1, that's what there? 40 millimeter in diameter. D2, that's what? 15 millimeter in diameter. D3, section 3 there has 30 millimeter in diameter. What am I giving again? I'm giving length, diameter, right? I'm giving force, F, as what? My force is being as what? 15 kilonewton. Mind you, I didn't say force is F1, F2, F3. This force is what works for every section here. 15 work for this, for section 1, 15 work for section 2, 15 still work for section 3, please. So I have this. This is my F. So I'm giving E to be what? 200 giganewton per meter squared. Now, my very first task to start solving is that, are we converting? Right? Are we converting, please? So I have to ask myself, are we converting? Of course, yes, we are converting. The idea of conversion in science is quite simple. Observe that my E is in what? Meter squared. I have to convert everything to what? To meter, right? So convert them to meter. What do I get here? It becomes 0.2 meters. So it becomes 0.5 meters, 0.2 meters, 0.04 meters. This becomes 0.15 meters. This becomes 0.03 meters. So convert them to what? Meters. I've converted to meter like this way, Abi. Next up, my force is in kilonewton, and my young loss is what? Giganewton. So I have to convert this giga to kilo. So note that giga is 10 to power 9, right? So the idea is now quite simple. Let's convert this. If I have my E to be equal to 200 giganewton per meter squared, how do you convert it to kilonewton? It becomes E is equal to 200 times what's giga? 10 to power 9. So 10 to power 9 Newton per meter squared. We know that kilo is 10 to power 4. K. Kilo is what? 10 to power 3. Sorry. 10 to power 3. So I'll remove 10 to power 3 from here. So I'll have that E is equal to 200 times 10 to power 6 times 10 to power 3 Newton per meter squared. Combine these two, I'll have 10 to power 9. Are you there? So I will change this one to be what? Kilo, because kilo represents 10 to power 3. So I'll have that E is equal to 200 times 10 to power 6. This one signifies kilo Newton per meter squared. So my real value for young modulus now, it becomes what? 200 times 10 to power 6 kilo Newton per meter squared. So observe that they are now uniform. So this is kilonewton, no problem. Meters, 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 and meter square. So they're still the same thing, please. So at this point now, I can now work by proceeding to solving these questions. So how do I solve this question now? It's quite simple. To solve this now is quite simple. What do I need to start doing? You know, we said we're looking for total elongation, right? And I have how many sections here? I have about 3 sections. Now listen up. We said that let's consider just an elongation alone. Elongation E is equal to what? FL over AE. Am I given F? Of course, that's 15. Number 2, am I given length? Yes, I'm given length for what? Each section. Section 1, 2, and 3. Am I given area? No. No. Yes. So I'm not do I do not know area, but I'm given what? Diameter. So I can now easily convert my diameter to what? To area now. So I need to get area. So at this point now, let's do area calculation, please. Now, for my area calculation, I'll have this section there. So for section 1, so area at section 1 now is equal to, you know that what relates area and diameter is that area is equal to what? Pi d squared all over 4, right? So to get area by area. So I'm given diameter. So to get the area now, I will record this formula here, right? So for section 1 now, that becomes pi d diameter 1 squared over 4. So pi, that's section 1, is d1 over 4. This becomes 3.142 times diameter section 1 is what? 0.04, 0.04 all squared all over what there? All over 4. This will give area section 1 will be equal to, if I multiply this, I'll have the 3.142 times 0.04 squared divided by 4. So I have my area to be 1.256 times 10 to the power minus 3. So area section 1 is there now. Let's do area at section 2. That's pi d2 squared all over 4. What's pi there? 3.142 times diameter section 2. At section 2 there, I have 0.15. 0.15 all squared all over what there? 4. What's my area at section 2? Area at section 2 will be equal to 3.142 times 0.15 squared divided by 4. I have about 0.0176, right? So observe, what's my unit? Meter squared, please. Meter squared. This is my section 2. Let's do area at section 3, please. Let's do area at section 3. Let's do area at section 3. Area at section 3 is equal to pi d3 squared all over 4. That becomes 3.142 times diameter section 3 is what? 0.03. So I have 0.03 all squared all over 4. So therefore, area at section 3 now will be equal to, multiply this through, so I have my answer as 7.0695 times 10 to the power minus 4. This becomes your value for area. So now the task is not quite simple now. Let's get this done, please. So we said the question says find the total elongation. The question says find the what total what the elongation. So this point now, the total elongation, that's ET now, will be equal to ET, total elongation is equal to what? E1 plus E2 plus elongation as what? Section 3. Because I have 3 sections there. 1, 2, 3. So I have 1 to 3. That becomes total elongation. Now, how do I properly solve this? That becomes total elongation is equal to what? Elongation itself is what? FL over AE. But mind you, for this first one, this is the formula here, Abi. They have the same formula, but what's different? My length is L1. For section 1, I'll have L1 here. Area is what? A1. Observe, please. F and E are used for everything. F and E are the same. We don't have F1 here, F2, F3. No. 15 is working all through. So since our FE are the same thing, I'll leave it there. Plus E is simply FL over AE. But as section 2, AD as section 2, please. Plus this one gives FL over same AE. But this is 3. This is 3. Now, mind you, observe that FE are the same all through. So what do I mean there? I'll now bring out F over E since they are constant. So into L1 over A1 plus L2 over A2 plus L3 over A3. So I have this, please. Perhaps square bracket. So round bracket. So I have this. So if I multiply this by this, I'll have this. Multiply this by this, I'll have this. Multiply this by this, I'll still have this. Just like mathematical approach, right? So now at this point now, let's simplify, please. What's my F? Of course, F is what there? 15. F is 15 all over what's E? Said E is what? 200 times 10 to the power 6. 200 times 10 to the power 6. So into what's L? 0.2. So I have 0.2 all over what's A1? A that's section 1. That's 1.256, perhaps 68 times 10 to the power minus 3. All right, minus 3. I'm done with this. Plus what's L2? L2 is 0.5. 0.5 all over what's A2? That's 0.017. 0.0176 plus, let's do L3, please. What's L3? That's 0.2. I have 0.2 all over what's it at section 3? That's 7.064. Sorry, 0695. 95 times 10 to the power minus 4. So it becomes what I have here. So I have this. So let's get this done, please. Let's get this done, please. So let's divide this, add it up, divide this, add value together. So what do we get? So from here now, what do we get as what? As our total elongation. So from here now, let's get this done, please. So another task is done here. So let's divide 15 by this first. So I'm saying that total elongation will be equal to, divide this by this. So if I divide 200 times 10 to the power 6, sorry. So if I divide 15 by 200 times 10 to the power 6, I'll have 7.5. 7.5 times 10 to the power 8 minus 8 per se into I'll divide each value here, right? I'll put the value here. So let's divide 0.2 by 1.256 times 2568 times 10 to the power minus 3. So I have about 159.13 plus, divide these two values. What do we get? That's 0.5 divided by 0.0176. I have about 28.409 plus, divide the other one there, 0.2 divided by 7.069, sorry, 6995 times 10 to the power minus 4. So I have about 0.2 divided by that value there. So about 282.9. So I have this. For me now, my total elongation is equal to 7.5 times 10 to the power minus 8 into, add them up there. I have 159.13 plus 28.409 plus 282.9. I have about 470.439. Combine these two, my total elongation now becomes this answer here times 7.5 times 10 to the power minus 8 there. So about 3.5282 times 10 to the power minus 5. Please, what's my unit? Elongation is what? In meters. So my answer becomes meters. So it becomes how to solve this particular problem. So we look at other past question now in the study of this course. Let's look at one last question and we're off.